Okay, good evening, everyone, and welcome to Engineers Ireland's Fire and Safety Division Committee presentation. This evening we have Noel, who is coming from us from the UK. He's going to give a presentation this evening on timber impregnation from a fire safety point of view. Just to let you know, Noel has 20 years experience in the aerospace industry. He worked as an IT business analyst, and he has worked locally and on global teams in relation to designing, writing, implementing, and supporting IT systems for the aerospace manufacturing industry. So, Noel, if you could just take over the slides there and you can start your presentation.
Thank you very much for the introduction. I suppose one of the bases of what this presentation is all about is looking at pressure impregnation for fire safety when it comes to wood products used in construction. As we go through the presentation, we're going to have a detailed look at the impregnation process, how we actually test and classify products that can be used in construction, and look at the other sides of that as well, and the additional things that we can actually test, and looking at the overview of what a CE certified process is. We'll have a little look at some of the alternatives that are also available on the market at the moment. But from our point of view, I'm the general manager at HALT, and we provide a specialist treatment facility for impregnated timber products to be used in construction. We were established in 2021, and we're a CE certified treatment facility, and we specialize only in impregnated timber. We produce timber for the construction market both in the UK and in Ireland as well, and we're located in Belfast. As I go through the presentation, it's good to give some sort of scope. I'll make reference to the machine that we use for this process. So it's a specialist piece of machinery called an autoclave. It's essentially a large vacuum and pressure chamber. Capacity is about 12 cubic meters at any one time, so we can very comfortably treat large volumes of timber. The machine's designed specifically for impregnating timber to achieve reaction to fire classification. And the software and the drying facility that we also provide is designed solely for this whole process. Because impregnation differs to a great deal from surface coating type application to achieve an FR product, we're actually considered a manufacturer. And with that in mind, there's a set process to actually establish a manufacturing system that allow us to actually produce impregnated timber with a reaction to fire classification. So I suppose at the outset, you've got to develop a process that works. But the key point to actually being able to produce timber products and put them on the market is that each timber species has to be classified, and has to be classified in the correct way. So we abide by harmonized standards set out for solid wood and wood-based panels. Once you have the materials tested and classification achieved, then the process must then also go through a certification process, and that's why you're able to actually offer a CE certified process. So the whole manufacturing from end to end is very closely controlled. Once you have that process in place, then you have to be able to verify that you are constantly able to produce timber at the right specification. And it all ties back into the way that you test materials and how you obtain a classification. So as a manufacturer, we offer a CE certified process. And when it comes to other options for achieving a reaction to fire for timber products, it's important to point out that the process that we use, the system that we use, the software and the machinery that we use goes through quite detailed auditing processes to make sure that any timber that's produced from an impregnation point of view is impregnated to the right standard, so whatever declared on that product is actually correct to the timber that's being produced. Impregnation has been around for quite a long time with regards to treatment for fungicide and other types of timber that may be used outside. But from a manufacturer's point of view, to achieve a reaction to fire classification for timber, the process is pretty similar. Only it uses similar pressures, but with a much greater uptake. Now, the whole beginning of the process of classifying a timber is to look at the timber that you want to test. So it is a species specific process. Each timber species that exists, I mean, there are thousands of different timber species that can't be sort of classified even within the same family. When it comes to impregnation, we got to treat each timber as a species on its own. I mean, there are various softwood species that exist within the same family, but when it comes to an impregnation point of view, each timber species is classified and tested on its own because they all have different material makeups, have different densities. Even the cell structure differs from species to species. So when we go through the process of impregnating a timber, we impregnate that timber based on how that timber was actually tested and achieved its own classification. So from an overview point of view, from an impregnation process, the timber is received into the facility and it goes through its own cycle of impregnation and penetration of the fire retardant. I must say that we've partnered or we use a cradle to cradle certified fire retardant during our process. So it's a highly environmentally friendly fire retardant. There are no toxic substances in the fire retardant itself. But timber comes into the facility and the timber is assessed for obviously the species that we're about to treat. It has to fall within a certain density range for that species. Moisture content of that timber is also critically important. We typically have a moisture content range between 11 and 22%. If the timber's too wet, then the process, we can't guarantee we'll get enough fire retardant into that timber. If it's too dry, there's potential for the cell structure of the timber to have been damaged through aggressive drying. So there's a lot of very important factors that need to be taken into consideration whenever you are actually impregnating timber. When the timber comes into the facility, there's more or less like a 4-stage process to it. The timber's loaded in, it's loaded in with the various parameters for that timber. And this is one of the key differences between impregnated timber versus surface coated or treated timber. We're actually technically changing the structure of that timber. We're impregnating the fire retardant into the very core of the timber. So it's not a one surface type application that only deals with spread of flame. We're affecting the whole timber. We're depositing the fire retardant into the very cell structure of the timber. And the first stage of that process, just to give you an overview, is that the timber is put under vacuum. So that creates negative pressure in the lower chamber, but it also opens up the cell structures of the timber and makes it ready and willing to accept the fire retardant that the process is now going to press into the center of the timber. Once the liquid fire retardant is flooded into the lower chamber, if you think back to the autoclave that we looked at, the timber has already begun to record or absorb levels of that fire retardant. Now, the process itself is not only species dependent, but it's volume dependent as well. So if we're loading a batch of 8 or 9 cubic meters at a time, the software that has been designed specifically for this process is able to calculate based on the density and the volume of that timber exactly how many liters need to be pressed into the core of the timber. And this all comes back to the testing process. Each timber species has a very different density range. Some of them are similar, but even within the timber species that we've tested, we'll have a range of different density ranges. So the software on the autoclave calculates down to the very liter how much liquid that we need to press into this batch of timber to ensure that we get the correct amount of fire retardant deposited into the core of that timber. Again, this comes back to how the timber was actually tested. If you've tested a timber and it's passed with 38 kilos of dry fire retardant per cubic meter, the process needs to guarantee that the timber is impregnated with a minimum of 38 kilos per cubic meter. So the software, the process ties in very closely to how the timber was actually tested and classified. And it's part of the manufacturing process that we got to be able to demonstrate and ensure that we have a constancy performance going forward with every timber species. So it's a very closely controlled system. And again, it goes back to the way that we provide a manufacturing process rather than an on-site application where you may not have the same controls. When timber is impregnated for fire safety, it's impregnated to the standard that it was tested, and the software controls down to the very liter how much fire retardant is actually pressed into the timber. So it's classed as a homogeneous or through and through process. So when timber is impregnated, you have the same fire protection on all surfaces of that timber. Even when we do plywood, we've classified quite a range of plywood products at this point, but the fire retardant is pressed right into the core of the plywood or the solid wood, depending on the species that we're treating at that time. After the solution has been introduced, then the process goes through up to 5 different pressure phases. It starts off quite slow. We work off an operating pressure range of 1 to a maximum of about 12 bar. And if you think about the process logically, the timber has the fire retardant on the outside at the beginning, but as the pressure increases and time increases, that liquid fire retardant is being pressed into the core of the timber. Throughout the whole process, there are flow meters measuring the amount of liquid as a difference between what was in the upper chamber and is now in the lower chamber, relating to the volume of timber that we're impregnating. And the process continues and continues until once it's finished, there's a guarantee there that the amount of liquid that was meant to be put into the timber has now been pressed into the center of the timber. So from a point of view, the software controls everything. It's a controlled process. One of the key critical elements to the end of it is just generally a basic calculation on weight increase. If we have a volume of timber that weighed X at the start of the process, and that material needs a minimum of 38 kilos per cubic meter, then very easily you can work out that the timber has achieved the absorption of the liquid based on weight increase alone. Once the process is finished, the timber is basically taken out and put into stick and dried. So we also offer a drying facility, and this is key to the impregnation process. If we're producing timber products for the construction market, they need to be ready to be installed, either on site or put back into storage. So you start with a raw timber product that might have a moisture content of 15%. After we have impregnated, the timber comes out with maybe in excess of 100% moisture content, but then it also needs dried back down so that the timber product being used in construction is ready for construction. So as an overview to the whole process, we're taking a raw timber product, we're changing the composition of that timber by impregnating liquid into the middle of it, and then that timber or that fire retardant is deposited in dry format inside the actual timber, and we can take a little bit of a closer look to see what's going on under the hood. This section in Norway spruce. Norway spruce is one of those materials that's actually a little difficult to impregnate because the amount of actual porous cell structure within the timber is it's quite low. It's only in around 10% of the cell lumina, compared to the likes of Douglas fir, which could be up to around about 40%. But if we look a bit closer at the pictures on the screen, you're actually looking at fire retardant deposited right on the cell lumina of that timber. So the two pictures on the bottom right, one's just achieved with an electro microscope, which shows a better contrast. So the crystals that you see on the cell lumina are dry fire retardant, and this is the key benefit of using an impregnation service to actually achieve a timber product with the declared reaction to fire. The fire retardant becomes part of the timber. It's in that timber, and as long as the timber doesn't decay, then the fire retardant will still maintain the same reaction to fire from the start of the impregnation process or the end of the impregnation process. If timber's impregnated with a classification of BS1D0, it maintains that same fire classification until the timber starts to decay. So if you think about it sort of logically, the fire retardant becomes part of the timber. If the timber is used externally and over a 5, 10, 15-year period, the timber begins to rot and decay, then naturally the fire retardant will rot and decay in line with that. So it is a through and through process. As we look under the hood and look at the microscope pictures here, we can see impregnating the timber with the fire retardant deposited, and it becomes actual part of the timber structure itself. So the process, as I say, it's a factory controlled process. There's factory production control to ensure and guarantee that you can achieve the same fire retardancy that is being declared on the declaration of performance of that timber. But I suppose the beginning of the process is that the classification process for producing a timber product is key and instrumental to this whole the whole service, or the whole service that we provide, or impregnation as a whole. There is a very clear classification process in place. I'm sure a lot of people are very familiar with the table that's on the screen at the moment. So it's the Euroclass system, which was established in around the year 2000, and it was a way of standardizing or harmonizing the reaction to fire for construction products across all the EU member states at the time. Up until that time, a lot of the local authorities had their own ways and methods of actually testing materials. So this classification process was introduced. It became mandatory from around about 2012 and went on to now replace the old BS 476 Part 6 and Part 7. But it's very clear in how it declares products to be used in construction. You have a reaction to fire classification A1, A2 down to F. A1 and A2 are generally regarded as they will not have no contribution to fire. And I suppose one of the key differences for this process or this standard as opposed to BS 476 is that it looks a lot more at the timber itself. It looks at or in this case, timber, it looks at the reaction to fire of the product that you're using in construction. From a timber point of view, timbers can actually be classed without further testing, and timbers generally regarded to be Euro Class D without any fire protection on it at all. After impregnation, we can bring timber from a Euro Class D up to a Euro Class B, so it's very limited contribution. So timber can never be classed as no contribution to fire. It's a natural organic material, and it will always give off some type of energy during the testing process. So timber can never be classified anything above Euro Class B. The second element to the classification process is actually analysing and looking at the smoke that is produced in the event of a fire or during the testing process. Smoke, I think, from the last stats I've seen, contribute to well over 60 or 70% of deaths in the event of a fire, either down to inhalation toxicity or even just visibility. So it forms a very key element to the Euroclass system. So we look at the product itself and we look at the reaction to fire of that product, but we also have to look at the amount of smoke that's produced during the testing process and how that material itself will contribute to smoke development in the event of a fire. So you're always looking for a product or trying to get the best product you can get, and S1 is the best portion of this classification system in terms of declaring your product. So the reaction to fire from construction point of view should be at best you can get as Euro Class B. We're looking for S1 for smoke, and the third element to that is actually assessing whether there are any burning droplets visibly measured during the testing process. So this classification system is very clear. It's very clear in how products should be declared for use in construction. We look at the reaction to fire of the product, we look at the amount of smoke that's produced, and we look to see whether there are any burning droplets. And all these elements are measured during the testing process. So again, when we're trying to achieve a classification for a product, we have to look at the material itself and how it reacts in the fire. Now, from a timber point of view, there are two harmonized standards for timber products. You've got 14915, which is the standard for solid, and 13986, which is wood-based panels, so plywood. Those two harmonized standards are very clear in black and white on what you need to do to achieve a reaction to fire. So it sets out the standard for reaction to fire for construction products to be the standard is EN 13501-1. Within that standard, there's two elements to achieve a classification for a timber product. 13823 is the key element to this. It's the SBI test. There's also an ignitability test within that as well, 11925, and both those elements are required for you to actually declare a product at Euro Class B. But the key thing for classifying a product, and this was introduced from 2018, that there are multiple ways of actually testing a product and achieving a classification. From an impregnation or from HALT's point of view, we have reclassified all our products to the latest standard, and it's a critical point to consider whenever you're procuring or using any construction product with a reaction to fire. The change from 2018 meant that you had to have notified body involvement in the testing process. So when any product's being put forward for testing and classification, the raw material is provided or sent to the test institute. Now, you can actually declare from a customer's point of view how much fire retardant in there, but if you choose to reclassify your products from 2018 onwards against 13501, a notified body needs to be involved in that whole process. So they oversee the impregnation. They do random sampling from the material that's put forward for a test. The material is then conditioned under control of the notified body, and then the test is carried out. So that's a very key thing for achieving a classification to the latest standard. The customer or the client who's putting forward for the test should not ever be involved in the testing process or the sampling. It needs to be notified body, because they come in and they will take random samples from the material that's put forward. And I suppose one of the key elements to that would be the likes of plywood or wood-based panels. You don't just test a full sheet of plywood. That plywood is cut up and random samples are taken from the material that's put forward. It's to try and guarantee that there are no major inconsistencies across the material that's being tested. A notified body included in that process is critical for it. The material is then conditioned for anything from 24 hours and up, to make sure that there's no change in the average mass of that timber, so it's very stable, and then it's put forward for the testing process. So as I said, there are two elements for 13823, which is the standard for the reaction to fire, 13501 standard. And the two elements of this are the SBI test and the ignitability test. So both those elements are mandatory if you want to declare a product Euro Class B. And the two tests are vastly different, but the SBI test has now become more or less the backbone of the Euro Class system. The SBI test is very comprehensive. It's the product or material that you're testing. It's a requirement that you go through this process and is exposed to a 30 kilowatt flame. During the process of the testing process, combustion gases are measured, smoke production is measured, heat release rate is measured, fire intensity growth rates measured, and if you think about it as a total system, we're testing a material to be used in construction, and we should be testing that material in construction and as close as possible to its field of application. And all these things are critical to ensuring that any product that is introduced to the construction sector has been tested accordingly, and we're looking at the material itself and assessing its contribution to the fire, not just a fire retardant product that may be applied either on top or even during impregnation. The material itself needs to be assessed for its own contribution to that fire, and the amount of smoke, the gases produced, and obviously just the behavior of the specimen itself. Because even though 13823 replaced BS 476, which used to look primarily under -6 at spread of flame, we need to now be considering materials that are used in construction for their reaction to fire and how much actually they contribute to the overall development of a fire. So I mentioned field of application. Field of application is critical for the construction product that is either being manufactured or sold or used in construction. This is a typical corner configuration that is set up for 13823, and there are different ways that you can actually do this test. You can set your test up to be fixed directly to a substrate. You can set your test up to be fixed on a cavity. You can set your material to be tested on a ventilated cavity. So I suppose the worst case scenario in those three events is that your material is mounted on what's classed the standard as a 40 mil ventilated cavity, and this is critical to the reaction of that material and how it'll typically be used on site. When we're talking about internal linings and exterior cladding, in a lot of cases, timber's very rarely ever mounted directly to a substrate. In most cases, there will be a cavity. There will be some sort of a battening system used so that you fix the timber directly to the battens rather directly to the substrate. But if you tested your material fixed directly to a substrate and then a user was to mount it onto a cavity, whether ventilated or not, it effectively would compromise the declaration of performance as provided by material, because you're now using it outside of its field of application. And this is a critical point to using or timber products in construction, it's essential that the end user uses the material or fits it in the way that it was tested. So if you look at the picture on the left there, it's actually a plywood sheet, and you can see that right wing is actually made up of lots of smaller panels. So it goes back to what I said earlier about having a notified body involved in the classification process. If you put forward a sheet good for testing, it's impregnated to standard. Everything is declared on the test article as in how much fire retardant is actually in there, the thickness of the material. When we're testing materials, we tend to test them with a range. You know, if a timber product is tested at 12 millimeters, then you cannot impregnate anything less than 12 millimeters and sell it on or declare its performance, because you haven't tested it. So it's critical that whatever way you've tested your material, that is declared as the product that you're producing during your manufacturing process. So in this case, the plywood's cut up, and that's a key element, because when plywood's generally fitted on site, there will be cuts made to that material. So impregnating timber, as you saw in the previous slides, deposits the fire retardant into the very cell structure of the timber. So there are essentially no limits to what you can do. You can cut it, you can sand it, you can drill holes in it. And this goes back to how it was tested in field of application. The material is cut up into small sections that replicates cuts on site. It's mounted on a corner configuration. In our case, we test all our materials on a 40 mil ventilated cavity, because that is classed or regarded as the worst case scenario. If a fire is exposed on the outside of this timber, as the heat increases on the fire side, you will end up with a buildup of hot air and gases on the underside of that material, and what happens is, if the fire penetrates, you will get spread of flame on both sides of that material. If you just have a surface type treatment that gives you spread of flame protection, there's potential for the fire to actually increase and spread on the cavity side of that building if it penetrates the surface. So from an impregnation point of view, or from any classification point of view for products used in construction, it's critical that the end user of that material is aware of the field of application in which it was tested. You think about some of the things that I discussed there. Was it tested on a cavity? Was it a ventilated cavity? How thick was that cavity? It's essential that the material installed on site is installed to the correct parameters in which it's tested in. Where impregnation excels over other types of reaction to fire or surface coating for a reaction to fire, is that the material itself has the fire retardant on all surfaces. It's also been tested at the correct standard, and therefore when you have a product on site, you have a lot more flexibility with it, and it will behave on all four sides of that timber the same as it would on the exposed side to the flame. So just a little bit about the SBI test. So the total test lasts in about 22 minutes, but from the purpose of the test, all the measurements are taken over a 20-minute period. The exhaust gases are measured, lead attenuation is measured, and on a typical test report, you will see the total heat release. You'll look at the fire intensity growth rate measured at two different calculations. You'll also look at the lateral flame spread, the total smoke production, and the smoke growth rate is also measured, and flaming droplets, as I said earlier. If you think back to the Euroclass system, it's looking for the reaction to fire of the material. It's looking at the amount of smoke that is produced, and it's also looking to see whether there are flaming droplets produced. So the SBI test, as I said, is generally regarded as the backbone to the classification process for the European standards. It goes a lot further than BS 476, Part 6 and Part 7. And just to recap, it looks at the material itself and its reaction to fire in the event of a fire. So in terms of field of application, then I highlighted quite a lot on the previous slides, but it's essential that the end user of a material being used in construction is fully aware of the field of application that material should be used in. It looks at the substrates, air gaps, whether there are joints in the material, what was the means of fixing the material during the test as well, because sometimes that can be very, very, very important. Was the material stapled to the substrate? Was it stable to the support patterns, or was it nailed, or was it screwed? Because if you test something with a weak fixing, or test something with a strong fixing and it's and then a weak fixing is used on site, then you have compromised the field of application for that product. So I'll come on to this a bit later, but when we're using reaction to fire materials in construction, it's essential that the end user is aware of the field of application in which it was tested, because it's critical to the whole process. So there are a number of accredited or certified test labs spread throughout Europe. These test labs work very closely with the notified bodies, but at the end of the full testing process, this is a typical reaction to fire classification report for a timber product. So I've highlighted some of the key elements there. So you get the reaction to fire of that product. In this case, we're looking at spruce. You've got the Euroclass rating, but the other key thing there is the field of application, and this is declared on the test report because these are the parameters that are identified during the test. Excuse me, that material or that information should then transfer through to the manufacturer of that product. So manufacturers are bound to create what's called a declaration of performance for the product that they're either selling, distributing, or putting into the market. So the figures or the information that's presented on the reaction to fire classification report should transfer into the declaration of performance, and that material should, or that information should, travel with the material. Once it's arrived on site, there should be a declared performance with the material, and the field of application should be very clearly set out. Was it tested on a cavity? Was it were there horizontal or vertical cuts in it? Because when we talk about fire and we're looking at the reaction to fire materials, it's essential that the field of application is adhered to. Otherwise, the validation of the test certificate and the declared performance they're nullified. A lot of people don't understand, or not, they don't understand, sorry, but it can be lost sometimes when we arrive, the material ends up on a construction site. Whoever's fitting that material might not have been made aware that you can't have horizontal cuts in it, that needs to be mounted on a cavity of some sort. So I think a lot of things that have come out from the Grenfell disaster is this concept of due diligence and the golden thread. It's essential that everyone involved in the whole value chain of construction is taking some sort of responsibility for sourcing, for manufacturing, sourcing, and supplying that material, and ensuring that it's installed correctly on site as well. So all these items come together, and they're critical to any product used in construction. That number one, has a declared reaction to fire, and has it been produced in a C certified process as well, because there are multiple ways of achieving reaction to fire, and we'll come to that a little bit later when we talk about surface applications. So there are further tests that can be carried out to verify the benefits of using an impregnation process, a pressure impregnation process, to produce reaction to fire materials. So one of the tests that we carried out with the University of Edinburgh was to perform a cone test. Now, a cone test is not a standard that we use in Europe for actually declaring the performance of a product, but it does give us an indication of the potential of the outcome of an SBI test, and the cone test has its own ISO 56601. And what it actually does, it measures the heat, or the potential heat given off on a small test article. And for the purpose of this, we can take impregnated timber, we can test it to standard, and then we can actually split that timber in half and test the inside of the timber. If you remember earlier, I spoke about how impregnation is actually depositing the fire retardant into the very core of the timber. We need to be able to demonstrate that, and this test helps us demonstrate that. So for this purpose, it was a section of thermopane, which was impregnated to standard. The cone test was carried out on the inside of the timber after it was split open, and you can see on the right hand side the predicted SBI test of that material was actually fell into the A2 category. Now, we can't declare A2 because we're working with a natural organic material. So in this case, after the timber was tested using this test methodology, the predicted figure scores were all very low, and we could actually be confident that material could still be declared as Euro Class B. Impregnation, I suppose it excels by changing the makeup of the material of the timber itself, but we need to be able to demonstrate that that material is durable, even in an external end use. So the fire retardant becomes part of the timber. If we're using a timber externally that isn't really designed to be used externally, something like a softwood with a very low or very high durability classification and like class 5, that material is going to degrade much quicker. So therefore the fire retardant will degrade in line with the timber. But when we look at some of the more durable woods, like thermal wood, we can actually demonstrate that the timber impregnation process is suitable for outdoor use. So 16755 is not a requirement. It's a testing standard that anyone can put their impregnated products through, and it was only devised in around about 2017 or 2018, and it was devised specifically to look at the durability of impregnated timber for use in construction. And there's a couple of different elements. There's two main elements to this test, but the end of that test, if you pass, you're able to declare that your material is used for interior and exterior applications. And the way you achieve a pass on this test, or the way that you put your material forward, is you follow the same process that you do for any testing, any classification process for a reaction to fire. Timber is selected, it's sampled, it's then impregnated to standard, but then the testing process is slightly different. We're looking at the hygroscopic properties of the timber. Does the fire retardant timber leach over time when it's put into a humidity chamber? And the other side of that is then we put it through, or it can be put through, accelerated weathering as well. So if we're using impregnated timber externally, it's important to guarantee that that fire retardant will not leach out of the timber over time. So again, timber is sampled, it's fire tested before it gets put through accelerated weathering, and that accelerated weathering test replicates something like about 150 years of exposure to both UV and rain. So, but the key thing for this standard is that you're testing prior to accelerated weathering, and then you're testing at the end of the accelerated weathering, and those two test scores must be the same. So we can do additional testing. We can test everything to the standard for a reaction to fire, but there are other tests out there that will help verify the benefits of impregnated timber to be used in construction. So we can test it as a through and through process by doing the cone test, and then we can also take it a step further and test it against 16755 for durability. So we can prove and demonstrate that the timber will not, or the fire retardant will not leach from that timber over time. So it's as good at the start of the test as it is at the end of the test. So therefore, we can declare that it's ideally suitable for an exterior use. So I said at the beginning that impregnation is considered to be a manufacturing process, and with that you need to have factory production control in place. And the key element to being able to certify your manufacturing process is by going through a regular audits with a notified body. So the construction products regulations is very clear. All timber products should be CE marked before they're able to be sold on the European market. When we impregnate timber, we're effectively changing that CE mark that came with it, because we're now taking a raw timber product, we're putting it through a secondary manufacturing process, and we're changing the declaration of that material. When we think about plywood as a good example, plywood will come with structural tests. It'll come with glue line tests. After we impregnate it, we're effectively changing the composition of that material. We're now adding to the original CE document, and therefore you need to have a CE process, CE certified process to do that, because we're not going to change the declaration of that material. It'll still maintain its structural integrity, but now we're declaring it with a reaction to fire. So from a manufacturing point of view, the manufacturer of impregnated goods needs to be providing a CE or UKCA certified process. Again, this is very clear under the harmonized standards. So when a product is placed on the market under construction products regulations, the manufacturer of that timber needs to be declaring or assuring that the performance of the product they're selling is the same as it was declared using the right European technical specification. So CE certification is critical to the whole impregnation process. A notified body needs to be involved in regular auditing of that manufacturing process. They need to be going through in great detail each production report that's produced to ensure that the material being produced is being produced to the correct standard. And it all goes back to the field of application and the testing process that was carried out. If a material is declared on the test report to have 48 kilos of fire retardant per cubic meter, the manufacturing process must ensure that it's getting at least 48 kilos of fire retardant per cubic meter into that product. And this is where CE certification comes in. Manufacturing processes are regularly audited by a notified body. There's actually a department in the UK now, the Office of Product Safety Standards, and they're out now regularly auditing as a secondary audit almost to the manufacturers or the producers of timber products in the market with a reaction to fire. So there's a roadmap to follow. As we saw at the beginning, you need to have a process, you need to have classification. You then need to have a constancy of performance certificate, which backs up the whole process. There are up to 4 different levels of AVCP. So it stands for Assessment and Verification of Constancy of Performance. It's a bit of a mouthful, but this is the standard that is set at European level to ensure that manufacturers or producers of fire retardant timber or any construction product with a reaction to fire are ensuring that their manufacturing process is producing timber products or any other product with a reaction to fire at the right level. So there's a couple of elements that you need to have in place. As I said, factory production control is critical to this. You need to have the right software or the right documented and audited process that guarantees the materials that you're producing are produced at the right level. After you've gone through an initial assessment with a notified body before you can actually go into production, they will issue or they'll issue the manufacturer with a certificate of constancy of performance. So, and that needs regular updating. It's at least annually. In the case of impregnation, depending on who the notified body is, test reports are regularly emailed to the notified body, or not test reports, sorry, production reports. They can ask for a production report or site visit at any time. And they can come in and go through in great detail and look at the production reports that are being produced for each batch of timber. If you remember earlier, I said that the impregnation process needs to be looking at timber species as a single species. You cannot mix, for instance, oak or pine in the same treatment process. It needs to be pine on its own. It needs to be oak on its own, and each timber species needs to have its own classification. We can't use a one-step approach for timber species, as I said, because they all have a different composition, they have a different makeup, with different densities. So the manufacturing process needs to replicate that same process. At the end of the whole CE certified process, then the manufacturer is liable or not liable, bound to produce a declared performance of that product. And again, it goes back to field of application. How was it tested? How was it classified? And how was it impregnated? Did you maintain the standard at which it was tested? So CE certification is critical according to the construction products regulation. Any product that is governed by a harmonized standard needs to have a CE certification or certified process which alters that product. So when we're talking about reaction to fire, all products on construction should be CE certified. And there are multiple ways of doing that. It's not just impregnation that can be CE certified. Coatings can also be CE certified. But I think it's very important to point out that if that product is governed by a harmonized standard, it should have a CE certification at the end of its manufacturing process. So there are other ways to achieve a reaction to fire for timber products. Impregnation is only just one of those ways. We can also produce impregnated, or not impregnated, we can produce reaction to fire timber products at manufacture. So MDF is a very good example of this, where the fire retardant is introduced at the manufacturing phase. So you're actually producing a product directly out of the factory with an inbuilt reaction to fire as it's been tested. There are other ways to achieve a reaction to fire by using coatings, for instance. And coatings, there's various problems with some coatings, and it all goes down to the way that it's actually being applied. There are actually computer controlled factory applicators out there who will apply a coating, a reaction to fire coating to a material, and they will be able to control the grams per square meter for each layer of that intumescent or coating that's purporting or producing the reaction to fire for the product. Some of the problems come in when coatings are applied on hand or on site by hand, because it's difficult to ensure the same quality control that you can get from a factory controlled process. The coatings that are on the market are now very clear, and that each layer of that coating should be applied in a very particular manner, right down to grams per square meter or coverage per tin, for instance. But it's hard to control that on site. The other issue is that from the declared performance on the product was it tested on the species in which I'm using it on. So, as I said from the outset, when we're impregnating timber, we got to deal with every single timber species on its own. The same should be done for certain coatings, but the key thing for looking at coatings is the quality control if they're installed on site. So there are some pros and cons for using all of these processes. From a coatings point of view, perhaps some of the main cons would be that there's a maintenance schedule built in to coating. So when we put a coating on a timber that declares a declared performance, for instance, the maintenance schedule needs to be adhered to for that particular coating. There's also potential for on-site damage. When we impregnate timber, the timber itself carries the reaction to fire. It's not a surface coating. The material has the fire retardant inside it, so therefore you can cut it. When it comes to coatings, if there's any damage to that coating, there's potential for the whole lining to be compromised. So that would be one of the biggest cons that I see with using a surface application for actually achieving a reaction to fire. Some of the cons, I suppose, from an impregnation process is that because it is a manufacturing process, there's quite considerable lead time sometimes, and those lead times are not down to the impregnation process, they're down to the drying process. It can take up to 4 to 5 weeks to dry plywood. So it's important that when we're impregnating timber, we're working with customers and clients, and we make them aware of the lead times, because it's not a solution that can be turned around or can be produced at hand. There needs to be some sort of scheduling put in place, and the drying process can be very slow for timber. With impregnated wood, it's also important that coatings are also tested, and there are a couple of different ways of doing this, but well, the main way to actually achieve a reaction to fire for a timber with a coating is that we first of all do the impregnation process, and then once we have achieved the classification, and if we have a Euro Class B for that timber, once a coating is put on that timber, it will potentially change the reaction to fire that was achieved prior to coating. So it's important that if we are producing or providing a coating solution for impregnated timber, that the coating has also been tested in conjunction with the timber itself. So we go back through the same process. We classify the raw material. We then coat the material using a certified process where we can very closely control the amount of coating that was put on. Now we're not talking about an intumescent coating in this case. It's just purely a cosmetic coating, but you have to be able to demonstrate that that coating that you're putting on, even if it's a water-based coating, doesn't alter the declared performance of the product as it was tested in its raw format. So we can achieve a certification and a classification for coated FR timber when it comes to impregnation, but we got to go back and redo the whole testing process. We take the raw product, we test it, we coat it, we test again, and at the end of that, then you have another CE certified option. You're taking your raw timber product and testing it again with a coating to make sure that it has the same declared performance. Just a little bit on documentation. So from an end user point of view, I went into great detail earlier to talk about field of application testing. When we're talking about products used in construction, from an end user point of view, they should always be looking for a DOP for that product. We're looking at the declared performance of the product that I'm using in my project. If a manufacturing process has provided that reaction to fire for the product that you're using, that manufacturer should also have that CCOP issued to them. And these two things are the backbone to the process that was used, and also the declared product that's being used on the construction product. So the DOP is really the key critical part to that. From an impregnation point of view, the impregnator should also be giving some sort of treatment certificate, and that treatment certificate in itself is worthless. But where it does come into its own is that when we're manufacturing impregnated timber, we're generally working on volumes. So we need to be looking at a range of different documents to try and translate a material that has now been fitted and measured in square meters on a wall versus the volume of timber that has actually been impregnated during the manufacturing process. So from a documentation point of view, the DOP is the key critical document for the declared performance of the product, but hand in hand with a treatment certificate, those two things can add to the overall documentation that the user should be asking for, so that they can translate the volume of timber that's been impregnated to a square meterage that's actually installed on site. So documentation is critical to this. Again, if I make reference to Grenfell, the Hackett report for the rest of the UK has been very clear on this concept of the golden thread. All parties involved in the whole value chain in construction need to be exercising some form of due diligence. They need to be comfortable, or at least very aware of the product that they're using, and documentation forms the key part of this. You need to be asking for a declaration performance of the product that you're using, and some sort of certificate or treatment certificate if it's an impregnation process, because those two things are the only documentation that the end user will have. So construction products and this concept of this golden thread relies heavily on the availability of documentation. So when we're using products with a reaction to fire in construction, we should always be looking for a DOP for the product. We're looking for the declared performance of that product, and as I said earlier, it's all down to the field of application and how it was tested. So with regards to the fire retardant from an impregnation process, impregnated timber has the fire retardant built into it. So it's actually in the cell, as we saw earlier on the pictures. If that material is exposed to heat source in the event of a fire, timber is very good at creating its own thermal barrier. When it starts to char, that paralytic or pyrolysis process that it goes through is the timber actually charring and trying to prevent the unburnt timber on the inside. But from an impregnation point of view, the first reaction of fire retardant is to actually add to that thermal charring. It slows down the process, it slows down that material and increases its reaction to fire. As I said, you cannot produce timber that have no combustibility. They will always have a limited or a level of combustibility. You can't prevent timber from completely charring through or burning, but it's important that whatever process is used to achieve the reaction to fire that is being declared, that it performs accordingly. So with regards to impregnated timber, the first reaction of the fire retardant is actually add to that thermal char on the inside. As the heat increases, then impregnated timber contains small water vapor droplets inside that crystal, and that water vapor is released if the heat increases. So combined, we're able to produce materials that resist ignition. They safeguard against heat release and just give people more time to escape from burning buildings. Timber is being used more and more in construction now. It's generally regarded as one of the most sustainable products that we have. So it's important that if we're using timber in construction, whether it be on a lining, structurally, exterior cladding, that we're not going to contribute to a fire. In the event of a fire, we're not going to produce or put products in there that are actually going to increase the spread of flame or the overall reaction of the timber product. So it's essential that whatever products we're using in construction from a timber point of view, that they have the desired effect that has been declared on that DOP for that product. Again, we're just trying to save lives and give people more time to escape from burning buildings. To sum up everything that sort of talked about here in terms of the impregnation process. A little demo created here, and what we were trying to demonstrate through this was how impregnated timber reacts differently to surface coated material. As I said at the beginning, when we test on a ventilated cavity, we have a cavity in behind that material that could potentially help increase the spread of flame on the inside of that material. So if fire was ever able to penetrate the lining that you're using on your building, it's important that the material is treated on all sides. So if you are going to use surface treatment, it's important that you coat both sides of that material so that you have some reaction of fire on both exposed surfaces. So if the fire gets through the lining, that the inside of that timber will also be able to perform as it was actually declared on the declaration performance of the material. So to try and demonstrate this, we created two small doll size houses out of birch plywood. One of them has 3 coats of off the shelf FR lacquer, and the other one is impregnated. And if I just play the video here. So the house on the right is the impregnated one, and the one on the left is the lacquered one. Now, the whole thing from start to finish, I think this took around about 12 to 14 minutes before the lining actually ignited. But you can see very clearly, as soon as the surface was compromised and the fire got through to the inside of the house in this case, it's trying to replicate a lining, you lose complete control of that lining. Vast amounts of smoke produced as well. You can see in the house on the right, even though it's exposed to the same ignition source, it charred and it burnt a hole through. But because you have a reaction to fire throughout the whole material, the material doesn't actually add anything to the fire. It just chars in line with the fuel source or the heat source that's being used. So if that was a lining on say a typical room that the furniture was burning on, that material would char in line with the furniture burning, won't add anything to that fire. So say 12 to 14 minutes from start to finish. The impregnated house was burnt through with the torch, but it didn't contribute to the overall fire. So I guess that's one of the key differences to using a coating option. If you're going to use a coating option, do it on all exposed ends. If you're going to cut material on site, make sure those exposed ends are treated. And if you're going to mount it on a cavity, make sure that you've got the underside of that material also coated. That will provide problems further down the line if you're trying to adhere to the maintenance schedule. And that's me finished.
Thank you very much, Noel. I actually understood most of that. Thank you very much. I had a copy of our own Irish building regulations here in front of me.
Yeah.
Section B2 and every EN standard, including BS standard that you referred to there as your facility testing. It's exactly in there.
Yeah, there's a part of that going back to 2005 where document B, technical guidance document B, actually recommends that surface treatment to achieve a reaction to fire, even against 476, is not it's not preferred. It's not the preferred method. So I know we're updating our technical guidance documents. It's still out for consultation, and we're expecting that to be released next year. So I think what you'll find is that there will be no more reference to BS 476. There will always be referencing the Euro class, which is the way that we should be going forward anyway.
Yeah. I just have a few simple questions. I suppose the advantage of this process, are you finding it from an Irish context, or from a more Eastern European context? Where are you finding that most of your business is coming from?
All our business, well, the vast majority of our business is in the UK, but we have supplied timber to quite a few Irish projects at this state. So, but the vast majority of our timber is being used in the UK. We're doing a lot of plywood. We've just recently tested 3 new plywood products, and quite a lot of the plywood that we're sending is actually used in construction. It's it's a material that's used during the construction process, but not as a finished lining. So there's certain requirements, for instance, for any project being used or working for London Underground. They use a lot of just construction grade plywood, eucalyptus plywood, which is one of the products that we've tested, and it's disposed of at the end of the process. It's not used as a final lining. So a lot of the timber we're supplying is going to the UK at the moment.
Okay. And what way is it arriving on site? Do you wrap it, or is it exposed to the environment once it arrives on site?
We will generally wrap. So when we get timber into site, we will keep the wrapping that it came in with, okay, and then it gets wrapped again. So there are certain sort of guidelines that you should be adhering to. You know, the timber, if we're producing timber and we've driven it back down to the correct moisture content, and that timber is to be used internally, don't leave it out in the rain, you know, store it flat. We go to great lengths to make sure that the timber is in a usable state on site right away. Now we do work with some larger, we've partnered with one large timber importer in the UK, and they're actually stocking our products. They're stocking the plywood products for distribution in the UK. But primarily our process, we're working with on a project by project basis. Essentially, you know, we're working with tier one contractors, we're working with architects being specified. So by the time it gets to the tendering process or the actual construction phase, then we'll get involved and we'll produce the timber upon request, almost, as long as we adhere to the lead times that are required for that timber.
Are you finding then that the assigned certifier is looking
Absolutely
for those paperwork, the
that
DOPs, the CCOP, or is he
yes.
handing it over saying this is what you need?
No, so
A bit of both.
a bit of both. I'm always trying to speak directly to the end user of this material to make them aware of the documentation that they need. So earlier on in the presentation, I talked about a treatment certificate and how that treatment certificate can be used. Now, it's essentially worthless. It's a document that I can produce to say that we impregnated 25 cubic meters of pine. But the reason why we now use this is on one of the projects we worked in, DFO asked. So when the science certifier is out on site, he's looking at 200 square meters of cladding on a wall. My paperwork says 10 cubic meters of timber. How do you translate the two? So we actually made a change to our process now. So if we're dealing with a cladding material, we're actually recording the square meterage of that material. So we will convert the 10 or 15 cubic meters into a square meterage, so that, and that's why I said the treatment certificate, whilst it's a worthless piece of paper from the product's point of view, it's a good piece of material that we can now marry up the treatment process, the manufacturing process, and what you're actually physically looking at on site, because the two things don't always translate to the same thing. So it's important that you are looking at 20 cubic meters, but listen, it's 500 square meters, you know, because that's important for the science certifier on site to actually sign off on the building.
And you yourself are arriving to some sites to have a post-installation review, or?
I haven't done anything on site. I have been involved in several Teams calls. But I don't often get to see the material on site, and sometimes I wish I could get to see a lot more of it and take more photographs. But
Yeah.
I can do that. But essentially, the documentation is critical to this. If we are producing timber, we issue a DOP with every batch of timber that we do. So that gives you your field of application. It gives you the declared performance of that product, because you might not have seen on some of those, but for our testing point of view, for standard construction materials, we'll declare BS1D0 for 15 millimeters up to 42 millimeters. Anything above 42 millimeters, because we're putting more fire retardant in, that changes the outcome of the smoke classification. And we're very clear on our declarations. So we will say 15 to 42 BS1D0, thickness is greater than 42 millimeters, BS2D0. So the reaction to fire stays the same, but you're dropping down a smoke classification simply because we're putting more fire retardant in there. And during our testing process, we witnessed more smoke being produced. So again, it's critical to the manufacturer, I suppose, that I want to provide the best documentation possible. So I want to make it easy for our end users to get final sign off on their construction project.
Yeah, I've seen a question come in there via chat. They were looking to see the price difference between fire coating and fire impregnation.
Well, you're not going to believe me, but we're cheaper. All our prices are based on cubic meters. Okay, so we have standard rates depending on the material per cubic meter. So a couple of different things can factor that. If you're using thicker material, you're going to get less value out of that cubic meter range. But I did this for my own sort of cost analysis. If you apply the right number of coats of the coating that you're putting on and do it with an approved applicator, you're going to be up in and around the £40 per square meter range. Impregnation, again, I can give you a ballpark figure. Plywood costs about 22 square meters to impregnate. If you're putting on thicker material or thicker cladding material, that price is going to go up. But we're close to half the price of a properly applied surface coating. And again, that's critical to what I'm saying here. If you just go into a hardware store and buy a tin of intumescent varnish and get your painter and decorator to put it on, it might be cheaper, but is it going to get the right performance? I don't know. We're providing a CE certified process, and if I do the cost analysis on 18mm plywood, we're almost half the price of doing the same with an intumescent or a reaction to fire varnish if done correctly.
Yep. Noel, honestly, I have tons of questions for you, but I'm really conscious of time, and it is late into the evenings.
Did I run over by long? Yeah.
No, not at all. Thank you very much for your presentation. It was exactly the detail that was needed to instill confidence into your system as well. Thank you very much for your presentation.
No problem. Thank you.
Thank you very much for all those who logged in this evening. And I'm not going to say it, but we'll see you all in the new year. It's still a little bit too early to say Merry Christmas, but sure, I think I just said it.
Thank you, Sinead.
Thank you very much, and all cheers.